Okay, geometric series and sequences. So basically what you're going to see here is all the things we did with arithmetic sequences and series, but geometrically. So it's a little bit different, where we have a different type of common ratio or common difference, right? We call it a common ratio, but then you're going to be able to find the next terms. You're also going to be able to write formulas, explicit formulas, and recursive formulas, and then find certain values. And then you're also going to, and there's geometric means along with the arithmetic means, and there's sums. So there's a lot to this one. So let's just get rolling with it because there's a lot to cover on here. But it's basically all the stuff we did with arithmetic, but with geometric. So there's just some slight differences. All right, so a geometric sequence is which the ratio between successive terms is a constant called the common ratio, okay? So instead of like adding and subtracting the common difference, in this case, you're going to divide any term following the first term by the preceding term. So you can pick any term you want after it's the first term, so pick the second term or the third term, whatever, and divide it by the one before it, and that gives you your common ratio, okay? Given a term of the sequence to find the next term, then we simply just multiply by that ratio, and we can get the rest of the terms from here on out. Okay. So while the rate of change of an arithmetic sequence is always constant, the rate of the change of a geometric sequence can either increase or decrease because you're multiplying. So if you're multiplying by a negative, it may change it back and forth, positive and negative. Okay. All right. So let's look at these. So let's determine the common ratios, and then we can find the next three terms. So it's pretty simple stuff. So instead of just like what we're trying to find what the difference was, the common difference when we were adding or subtracting here, now with the common ratio, we're going to divide. So what we do here is we take two terms just to make sure it's correct. So I'm going to take this term here, 11, divided by 4, and I get 2.75. Now be careful because that just doesn't always mean it's going to be that way, because there could be situations where you divide and you don't get a common ratio, and then therefore it's not a geometric sequence. Okay, so we got to take the next term too and just check it. So we got to take this one here and divide it by 11, and you get the same number of 2.75. So now I know that that is my R value. That's my common ratio, which then I can add that, or sorry, then I can multiply by 2.75 over and over and over again to get my next values, but I have to multiply it, okay, rather than add it. So my next values then would be, I think it comes out to 83.1875, comma, 228.765, 625. And notice I'm not rounding here because when I round, that's when I'm going to have an issue with getting the exact numbers because I'm multiplying by the whole number of 2.75. So, to get the correct sequence numbers, then, I have to kind of write them all out because I had to take all of this value here and divide it by this one to get 2.75. But if I don't put all the decimals, it's not going to be exactly 2.75. Hopefully you got that. Okay, so the next one. Now we have some variables in there. Same thing, no big deal. We're just going to go ahead and divide. I got to take the second term, right, and divide it by the first. 16R plus 32 divided by 64R minus 128. Okay, easiest way to go about that is to factor. So the first one, if I pull out a negative 16, I'm going to have R minus 2, right? Think about distributing. Negative 16R, positive 32 has to be an R minus 2. On the bottom, if I take 64 out, then I have R minus 2 as well. So then those two can cancel, and I have a negative 16 over 64, which equals negative 1/4. Okay, so now I got to check again that the same thing is good here. 4R minus 8, because if it's not, then it's not a geometric sequence. Divided by negative 16R plus 32. Okay, so let's factor some stuff out here. If I go 4, this would be R minus 2 kind of already did this one, negative 16, r minus 2, so I can cancel those out. So again, I have 4 over negative 16, which is negative 1/4. So those check out. That would be my r value there. Okay. So now I'm going to have to multiply these by negative 1/4. Keeps going, negative 1/4. And so what I end up getting is my sequence would be negative r plus 2, comma, again, multiplying by 4, so r over 4 minus 1/2, and comma, negative r over 16 plus 1/8. Okay, those will be the next 3 items in the sequence. All right, so thinking about that. Actually, thinking about that, also thinking about how we talked about how they could increase or decrease. Okay, so in this case, we've got, it went negative, then it went to positive. It was negative here, then it went to positive, then it went negative, because it's not going to be like a common difference where it's always getting larger or always getting smaller. This might hop back and forth because our r value was negative there. So that makes a difference here. Okay, and I'm kind of letting you do the calculations, just, go with it. All right, so here we go. Here's the expanded form of this. And we just want to point this out, that when you think about it, exponential form, this kind of just talks about how you have a1. Then the second term would be a1 times r. And then r squared would be the next one. R to the third, r to the fourth. So that's kind of what you're doing, is you're multiplying by the same number over and over and over again. So when we do that, you're just kind of multiplying by that r value over and over. R to the third power, r to the fourth power. And that's why we have these sequences that kind of grow like that. When you get to the nth term, it would look something like this. And we have this general thing, general formation here, a1 times r to the n minus 1. We'll use that later on when we're talking about sums and stuff. Okay, so just remember that this key here, just because it's not arithmetic does not mean that it's actually geometric. So you should test several terms. That's why we're testing the second and third, to make sure it is geometric, because it might not be. Okay, just wanted to point that out. Okay, let's talk about the nth term. So the nth term can be given by this here. Nth term of the geometric sequence, the first term of a1 is given by this. A sub n equals a1, that's the first term, a sub 1 times r to the n minus 1 power. Use that a few times here today. So we could plug that in, they give you an example there. Let's talk about finding the value of a common ratio, or write an explicit formula. So to write an explicit formula, you're going to find that r value. That's the first key. And then you're going to substitute a1 and r into this formula right here. Okay, you do that, and that's how you're going to write an explicit one. Very similar to like the arithmetic. With recursive, you're just going to state that this is a1, and then you're going to write it as a product, not a sum, a product of the previous term and r. Okay, so let's show an example of that, how it works, and we'll go with it. We'll move on. Okay, so explicit formula, recursive formula. So let's start with an explicit formula. Okay, so explicit formula here. All right, so we know we want to use this. An equals the first term, a sub 1 times r to the n minus 1. So what do we know? We're going to say a sub n equals, the first term is 2. Okay, my r value, I have to kind of do some math to figure that out, but it comes out that it's, trust me on that so we can move a little quicker, it's 12.5 to the n minus 1. Okay, again, my a1 was 2, we know that here, and my r value is equal to, so I take these terms, 25 divided by 2 equals 12.5. Again, I had to test multiple terms, so I go 312 divided by 0.5 divided by 25 also equals 12.5. So that's how I know that my r value here is 12.5. And so I can sub that in the formula. A1 is 2, r is here, and that's how I get my explicit formula. For the recursive formula, just written a little differently. Remember, they just say state that what a1 is. So a1 is equal to 2, and then we want to put a comma, and we just want to say that these two are products of each other. So a1 equals product of r times a to the n minus 1, which is the previous term. So that's all they're saying there with the recursive formula. So find your r value first, then you can plug it into the formula here and with your a1. Okay, let's move on. Find the specified term of each geometric sequence with the given characteristics. So now they might want a certain term. In this case, they want a sub 9, right? So what do we know? We got to use that formula and find out what we have to, and get what we have to find out. So I've got a sub n equals a1 times r to the n minus 1. So what I need my a sub 1, which I know is 4 here, and I need an r value, okay? For r, I take those terms, I go 14 divided by 4, second term divided by the first term, and I get 3.5. If I take the other one, 49 divided by 14, I also get 3.5, so that's good. It means my r value is 3.5. Now I can plug it into the equation here. And I can say, since I'm trying to find a sub 9, I can say a sub 9 equals 4. That was a1 times 3.5 to the n minus 1, right? So the 9 minus 1 power. So essentially it's 4 to the 3.5 to the 8th power, which when you calculate that out, comes to about this value here, 90,075 and 0.02. Okay. All right. How about the next one? They want A12. A12. Okay. So again, using the same formula, nothing there has changed. It's still going to be sub n equals a1 times r to the n minus 1. So in this case, again, I got to find my a1. Well, a1 is a little bit trickier here because I don't have that yet. They gave me a3, so I had to kind of work backwards a little bit. So I could find a2 by saying, all right, 32 is a3 divided by, I got my r value of -4. So I can say a2 would be 32 divided by -4, sorry, which would be -8. And then that means a1 would be this -8 divided by -4, kind of working backwards with my r value. So a sub 1 would equal 2, right? Because they didn't give me that, so I had to work backwards to get it. So a sub 1 equals 2. I've got my r value here, so now I have enough information to plug in. Trying to find a12, right? So a12 equals a sub 1 is 2, r is -4 to the 12 minus 1 power, okay? Or the 11th power, right? So now, just make sure you do order of operations correctly. A sub 12 would come out to about, I should say, because we're going to crazy decimals here, 8,388, or 8,388,608. Okay. So just finding different ways to get those values. If you get your A1 and you get your R, you're in good shape. All right, let's talk about this watercraft. Now, a little bit different example here. So in this case, Rohan purchased a personal watercraft for $9,000. Assume that by the end of each year, the value of the watercraft depreciates by 0.30. Okay, so one thing we have to think about with these types of problems is that we kind of have to adjust the formula because now we're not really given an A sub 1. And instead, this is kind of going to be the value of A sub 0. Okay? Because we don't have one. So we kind of just have to adjust the formula here, which is a little bit tricky, but just think about it in terms of these real life scenarios. You'll have an A sub 0, say, because they already purchased it. And that was the original price of A sub 0. All right, the other thing we have to look at is it depreciates by 30%. So that means it's going down by 30%. So that means it's going to be worth 0.70 of what it was, right? So we're going to multiply by 0.70. So that actually becomes the stuff that I need there. So that is going to be kind of the information we need. So when we write that out, again, nothing's changed with the formula. I'm still using that same formula. A1, well, in this case, it'd be A sub 0. And then we're going to use, normally it was A sub 1 times R to the n minus 1. So now what changes here is that this becomes kind of a sub 0, and then we don't necessarily need the minus 1. So all we're kind of looking at here in this case is A sub n equals A sub 0 times R to the n power. Okay? So for part A, my A sub n is what I'm trying to find. My initial value is $9,000. My R value, we talked about that 0.70, because if it's going down by 30%, that means it's worth 70% of what it was originally to the n power. Okay? That's the equation for the first one. And then for B, we're looking at n is equal to 5 years. So then if I plug 5 into the equation here, I can calculate that out, and I get it to be, after 5 years, it's worth this much, not as much. It went down to $1,000, $1,500 from the 9,000. Okay, so we talk about adjusted formula here. All we're talking about here is, because it's A sub 0, now it's not n minus 1, it just becomes n. You don't have to do the subtraction. So kind of when we talk about it in those terms. So if you see that type of thing, I can help you out with what formula to use if you have to adjust the formula or not. Usually it's when you purchase something originally with the price, and it's not necessarily a sequence one. It's like one of those real world examples. All right, geometric means. So terms between two non-consecutive terms of geometric sequence. Okay, and what we do here, so it's kind of like the arithmetic means, it's the terms between two different sequence terms that are not next to each other. So use the given information that you have, find the nth term, and then you can go from there and you can fit it in the middle. So let's do that. So indicated for -4 and 3.5, and we've got two means, it says. Okay, so two means, that tells me that n is equal to 4, right? Because you have 1, 2, 3, 4 terms. So n is equal to 4. You're going to have two means in the middle. I know my A1 is -4. And I know my A to the 4, A sub 4 is 13.5. So I'm looking for those middle two terms. All right. So again, I'm basically using the same formula. In this case, I know that, but I'm kind of working backwards here, right? So I've got A to the 4, A sub 4, not to the 4, A sub 4 is going to be A sub 1 times R to the n minus 1 power. Okay, so let's plug in the values I know. I know that A sub 4 is 13.5, so I can plug that in on the left-hand side. And then I can go -4 is my A1, because I found that also. I just don't know my R, and it's going to be R to the 4 minus 1 power. Right? We know that that's 4. So R to the 3rd power. Now I have to kind of work backwards here. So I'm going to divide by -4. So that's going to give me R cubed equals like -3.375. Then I got to take the cubed root here to get R equal to -1.5. So make sure you do that in your calculator to get that. And now that's R is -1.5. So now I can find the sequence here by saying, well, it would be -4, comma, and then I'm going to multiply. Remember, multiply by 1.5, which gives me 6 by -1.5, right? The next one then would make it -9 because I'm multiplying, and then I would have 13.5. But really, remember, you're looking for those middle two terms. There they are. Okay, so let's try this next one. Again, all I need is the same formula. So A1 equals 10. N is equal to 5 now because I got 1, 2, 3, and then 4, 5 terms. And I know that my fifth term, a to the sub 5, is going to be 0.016. So I have enough information to plug this in. So I'm going to go a sub 5. And then I'm going to go a sub 1 is 10. And r to the 5 minus 1 power, which is, I know this value here, so 0.016 equals 10 to the r to the 4th, 10 times r to the 4th. So I divide by 10, 0.0016 equals r to the 4th. Now I'm going to take the 4th root, okay, 4th root, to get r isolated, and r is equal to 0.2. Remember, when we do this, we have to multiply by 0.2 and then multiply by 0.2. So our sequence would look like this. Sequence would be 10, then we multiply by 0.02 or 0.2 and you get 2. Then you multiply by 0.2 and you get 0.4. And then you multiply by 0.2 and you get 0.08. And then you can see how you get the next one, 0.016. But these three were the three geometric means in that sequence that we are looking for. All right, moving along. We are cruising. Let's get into the next part, which is geometric series. And you can always go back and rewatch. I'm just going to tell you that because sometimes we just zip through these things and then we forget. And I'm going fast because there's a lot to cover. Let's talk about the geometric series. Here's the sum of the terms of this sequence. So I'm going to add them up. There's a couple different formulas we can use. One is this one here. Second one is this one here. Either of them works depending on what information you're given. Okay. Sum of the infinite geometric series. If we have an infinite one, we would use this formula here. Okay. So we kind of got three different formulas. If we have any two of the three variables, being s, a sub 1, and r, if you have any two of those are known, you can always solve for the third. Okay, so we've got lots of examples to go through. Let's get to it. All right, first one here. So 6a, find the sum of the first 11 terms of this geometric series here, and it kind of goes on and on. All right, so they want the first 11 terms, so they give us a finite version because they give us 11. So we're going to use one of those first two formulas up here because it's not infinite because they say the first 11 terms. All right, so when I think about this one, let's go 6a right here. When I think about this, I need my a1. When I look at the formulas, what I need, a1 is equal to 7. I'm also going to need my r value. So to get my r value, I have to do certain things, right? So to get that, I'm going to take these terms, negative 24.5, and divide it by 7. And it comes out to negative 3.5. If I use this one as well, 8575, and divide it by the term before it, negative 24.5, I end up getting the same thing, negative 3.5. So I know my R value is negative 3.5. All right, so I'm in good business. Now I can use the first formula there. So I can go ahead and I say Sn equals, what's the formula? A sub 1 times 1 minus R to the n power over 1 minus R. So do I have enough of that information? I sure do, because I'm looking at getting 11 now, right? So I'm going to go S11. Sum of the 11 equals A1 here is 7, right? And then in parentheses, I got 1 minus R to the n. Well, R I know is negative 3.5. N is 11 because that's the 11th term that we're trying to find, over 1 minus r. So just be careful here because 1 minus a negative 3.5. So we know we're going to have to choom that. And then when we figure that out, we can go ahead and do that math. And that comes out to, I'd say, a very, very large number here. There you go, plugging in the numbers into the formula. Okay, let's look at 6b. Okay, so 6b here now. Okay, so let's go ahead and, now in this case, we use formula 1 here. Let's go ahead and use formula 2 on this one. So what we have is, because they give us the a to the n, because they gave us that version, I can use formula 2. Okay, so I'm going to use formula 2 on this one because of what we have. All right, so I'm going to go with S sub n equals, I'm going to have all this stuff, a1 minus a sub n times r over 1 minus r. Okay, because I have those values. They gave me a1, they gave me an. So, and they gave me r. So they gave me all of the things I need. So I can just plug in and go from here. So in that case, that means that S sub n is equal to a sub 1 is the first term, that's negative 8, minus a sub n is 131,072 times r, which is negative 4. They gave us that as well, all over 1 minus a negative 4. So again, it's going to turn positive, but you can calculate that one out. And so we'll end up with a number here, 104,856. Okay, so depending on what information they give you is the formula you can use. All right, so what if they put it in sigma notation? Because that happens too. Okay, so let's go ahead and try that. They put it in sigma notation, we can do it. So first things first, we just need to find an n, we need an r, and an a1. Okay, so let's just go ahead. And in this case, remember when it's in sigma notation, you're going to take the upper bound, 31 minus 16 plus 1. So n is going to be equal to 16 in this case. Okay. R is equal to 2. Now, how do I know that? Because it's the base of the exponential here. So when it's in sigma notation, R becomes pretty easy because remember, when we get the very first page here, what we're doing is we're multiplying by powers of R. So when we get it into this form here, your R value is the base. So R is easy to find in this case. So I know that my R is 2. And now I just have to do a little bit of work to find my a sub 1. So I've got R equals 2. I got n equals 16. How about a sub 1? So now I'm going to plug in the value, 0.5 times 2. Okay, well, a sub 1 is 16, right? So 16 minus 1 here. And I can kind of do the math there. So it's actually 0.5 times 2 to the 15th power, which comes out to 16,384. Okay, now I have enough to do the formula. I've got my A1 and I've got my R and I've got N. So I'm ready to go. So I'm actually going to use formula 1 here. All right, and I'm going to get looking for S of the 16th term because that was N, right? N is 16. So the first 16 terms, I'm going to use my a sub 1, 16,384, times 1 minus 2 to the 16th power, because it's 2 to the n, over 1 minus r, which is 1 minus 2. And that gives us a very, very large number. We calculate that out. Just be careful with your calculations. You can do it in the calculator. I'm just saving time with that. Comes out to this. You might have to use the answer key, right? Second answer to get that one. Second equal sign or whatever your calculator does but that would give us that answer there. All right, next one, 7b, same thing. I can find n. N is going to be 11 minus 4 plus 1. So n is equal to, in this case, 8. Okay, so that's key to know. I know that my r value, remember, is going to be the base number. So r is equal to 0.5. So that's good to know. And now I just have to do a little bit of work to get a sub 1. Okay, so a sub 1 in this case would be 120 times 0.5. Now, we're talking a sub 1 is 4. That's the lower bound. So it'd be 4 minus 1, which is 3 here. So a sub 1 would actually come out to 15 here. So I've got all the information I need. I can plug it right into form 1 here. And I can go. Okay. So when I do that, I've got all my stuff I need. So I just go S of 8, because that's our n value, equals a sub 1, 15. And that's going to be 1 minus 0.5 to the 8th power, to the nth power, right? To the 8th power over 1 minus 0.5. So again, do your exponents order of operations, do your exponents first, and you're going to get about 29.88. Okay. Now, if you wanted to, you could do form 2 here. You just have to find form 2. You just have to find an a sub n. So you'd have to just kind of plug in your n value, a sub 8, and you'd end up getting like 0.9375, but then you'd have to plug it into the form 2 equation. Just thinking about that, if you wanted to use form 2, you should come out with the same answer. Okay, but I just used form 1 because it's all there for us. All right, last one's the infinite sum. So the infinite sum here, we're using this formula here because this is an infinite geometric series. Notice it's denoted because it goes dot, 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 dot. So that's what that does. So here we go. In this case, the formula is pretty simple. This one's probably the easiest formula. You go S equals a sub 1 over 1 minus r. So I need an a sub 1 and I need an r. Well, I've got a sub 1 is 10. My r value I can find, right? Pretty simple. I just divide -5 by 10. And I should also go 2.5 divided by -5 to make sure they're the same. And I get -0.5 for both of those. So I know that's my r value. So I can plug that in. So I think S here, the sum of this would be 10 is my a sub 1 over 1 minus a -0.5. If you do that math, you're going to get like 6.66 repeating here. Okay. All right, next, 8b. So same idea. A1 here is 20. Okay, let's look at my r value. If I go 15 divided by 20, I get 0.75. How about 10 divided by 15? I get 0.667. Uh-oh, that's why we test those, right? Because now I can see those are not the same. So I don't have an r value, meaning this sequence is not geometric. So this sum does not exist. Can't find the sum because it's not a geometric sequence because your r value does not match up. There you go. That's why you test multiple. Okay. All right. So let's get to the last one here. This one we can do with infinity. It is an infinite sum because of this infinite. All right. So a sub 1. Well, I do have to do a little bit of work here because I can take the first term. It's not in there. So I just go a sub 1 is 120 times 0.8 to the 1 minus 1 is actually to the 0 power, right? 1 minus 1 is going to be 0. So that's going to be 1. So it actually works out nicely for us because anything to the 0 power is 1. So a sub 1 we know is going to be 120. Then I'm good to go. I know my r value is already given here, the base number of the exponential function, 0.8. So I can use the sum formula. I can go a sub 1, 120, over 1 minus r, 1 minus 0.8, 0.2 in this case. And when you do the math here, you're going to get 600 for your sum. Woo. We covered a lot of ground there. So take your time, rewind if you need to, do what you have to do. That's a long one, but had to be done. We'll see you next time.